Amazon Elastic Compute Cloud forms a central part of Amazon.com's cloud computing platform, Amazon Web Services, by allowing users to rent virtual computers on which to run their own computer applications. EC2 encourages scalable deployment of applications by providing a web service through which a user can boot an Amazon machine image to configure a virtual machine, which Amazon calls an instance, containing any software desired. A user can create, launch, and terminate server instances as needed, paying by the hour for active servers, hence the term elastic. EC2 provides users with control over the geographical location of instances that allows for latency optimization and high levels of redundancy. In November 2010, Amazon switched its own retail website to using EC2 and AWS. History. Amazon announced a limited public beta test of EC2 on August 25, 2006, offering access on a first-come, first-served basis. Amazon added 2 new instance types on October 16, 2007. On May 29, 2008, 2 more types were added: high CPU medium and high CPU extra large. There are 12 types of instances available. Amazon added 3 new features on March 27, 2008: static IP addresses, availability zones, and user-selectable kernels. On August 20, 2008, Amazon added Elastic Block Store. This provides persistent storage, a feature that had been lacking since the service was introduced. Amazon EC2 went into full production when it dropped the beta label on October 23, 2008. On the same day, Amazon announced the following features: a service-level agreement for EC2, Microsoft Windows in beta form on EC2, Microsoft SQL Server in beta form on EC2, plans for an AWS Management Console, and plans for load balancing, auto-scaling, and cloud monitoring services. These features were subsequently added on May 18, 2009. Amazon EC2 was developed mostly by a team in Cape Town, South Africa led by Chris Pinkham. Pinkham provided the initial architecture guidance for EC2 and then built the team and led the development of the project along with William Van Bilhon, Roland Patterson-Jones, Christopher Brown, Quintin Houle, Peter DeSantis, Marcin Kowalski, Benjamin Tobler, James Greenfield, A.T. Eli Jurgensen, Alan Powell, Eden Adogla, Lehan Lutz, David Brown, Anton Eicher, Christopher Descartes, Greg Kemp, Real Smith, Jeremy Thurgood, and Andres Dippenar. Elastic Compute Units. The Elastic Compute Unit was introduced by Amazon EC2 as an abstraction of computer resources. Amazon's definition of AQ notes, "We used several benchmarks and tests to manage the consistency and predictability of the performance of an EC2 compute unit." One EC2 compute unit provides the equivalent CPU capacity of a 1.0 to 1.2 GHz 2007 Opteron or 2007 Xeon processor. This is also the equivalent to an early 2006 1.7 GHz Xeon processor referenced in our original documentation. Elastic Block Storage. The Amazon Elastic Block Store provides raw block devices that can be attached to Amazon EC2 instances. These block devices can then be used like any raw block device. In a typical use case, this would include formatting the device with a file system and mounting it. In addition, EBS supports a number of advanced storage features, including snapshotting and cloning. EBS volumes can be up to 1 terabyte in size. EBS volumes are built on replicated storage, so that the failure of a single component will not cause data loss. EBS was introduced to the general public by Amazon in August 2008. Instance types. EC2 uses Xen virtualization. Each virtual machine, called an instance, functions as a virtual private server. Amazon sizes instances based on elastic compute units. The performance of otherwise identical virtual machines may vary. As of December 2012, the following instance types were offered: on-demand, pay-by-hour without commitment, reserved, rent instances with one-time payment receiving discounts on the hourly charge. Spot bid-based service runs the jobs only if the spot price is below the bid specified by bidder. The spot price is claimed to be supply-demand-based. However, a 2011 study concluded that the price was generally not set to clear the market, but was dominated by an undisclosed reserve price. Cost as of July 2014, Amazon charged about $0.013 per hour for the smallest micro-instance virtual machine running Linux or Windows. Storage-optimized instances cost as much as $6.820 per hour. Reserved instances can go as low as $4.50 per month for a 3-year prepaid plan. The data transfer charge ranges from free to 12 cents per gigabyte, depending on the direction and monthly volume. AWS pricing came under scrutiny due to the complexity of the pricing model. Third-party vendors, such as Cloud9 and CloudCheck, offer fee-for-service analysis to help reduce costs. However, such are the potential savings from switching virtual servers off when they're not required that products that enable real-time on-demand scheduling are rapidly being developed by third-party vendors, such as ParkMyCloud and Cloud Machine Manager free tier. As of December 2010, Amazon offered a bundle of free resource credits to new account holders. The credits are designed to run a micro-sized server, storage, and bandwidth for 1 year. Unused credits cannot be carried over from 1 month to the next. Reserved instances. Reserved instances enable EC2 or RDS service users to reserve an instance for 1 of 3 years. The corresponding per-hour rate charged by Amazon to operate the instance is much less than the rate charged for on-demand instances. Reserved instances can be purchased in 3 different ways: all upfront, partial upfront, and no upfront. The different purchase options allow for different structuring of payment models. Comparison table features. Operating systems. When it launched in August 2006, the EC2 service offered Linux and later Sun Microsystems' Open Solaris and Solaris Express Community Edition. In October 2008, EC2 added the Windows Server 2003 and Windows Server 2008 operating systems to the list of available operating systems. In March 2011, and ETBSD Amos became available. In November 2012, Windows Server 2012 support was added. Since 2006, Colin Percival, a FreeBSD developer and security officer, solicited Amazon to add FreeBSD. In November 2012, Amazon officially supported running FreeBSD in EC2. The FreeBSD EC2 platform is maintained by Percival, who also developed the secure deduplicating Amazon S3 cloud-based backup service Snap. Amazon has their own Linux distribution based on the Fedora and Red Hat Enterprise Linux as a low-cost offering known as the Amazon Linux AMI. The version 2013.03 included Linux kernel version 3.4.34, Java OpenJDK runtime environment, GNU compiler collection GCC, x86_64 4.4.6-3.45. Amazon 1. Persistent storage and EC2 instance may be launched with a choice of 2 types of storage for its boot disk or root device. The first option is a local instance or disk as a root device. The second option is to use an EBS volume as a root device. Instance store volumes are temporary storage which survive rebooting an EC2 instance, but when the instance is stopped or terminated, this store is lost. EBS volumes provide persistent storage independent of the lifetime of the EC2 instance, and act much like hard drives on a real server. More accurately, they appear as block devices to the operating system that are backed by Amazon's disk arrays. The OS is free to use the device however it wants. In the most common case, a file system is loaded and the volume acts as a hard drive. Another possible use is the creation of RAID arrays by combining two or more EBS volumes. RAID allows increases of speed and/or reliability of EBS. Users can set up and manage storage volumes of sizes from 1 GB to 1 TB. The volumes support snapshots, which can be taken from a GUI tool of the API. EBS volumes can be attached or detached from instances while they are running, and move from one instance to another. Simple Storage Service is a storage system in which data is accessible to EC2 instances, or directly over the network to suitably authenticated callers. Amazon does not charge for the bandwidth for communications between EC2 instances and S3 storage in the same region. Accessing S3 data stored in a different region will be billed at Amazon's normal rates. S3-based storage is priced per gigabyte per month. Applications access S3 through an API. For example, Apache Hadoop supports a special S3 file system to support reading from and writing to S3 storage during a MapReduce job. There are also S3 file systems for Linux, which mount a remote S3 file store on an EC2 image as if it were local storage. As S3 is not a full POSIX file system, things may not behave the same as on a local disk. Elastic IP addresses. Amazon's Elastic IP address feature is similar to static IP address in traditional data centers, with one key difference. A user can programmatically map an Elastic IP address to any virtual machine instance without a network administrator's help and without having to wait for DNS to propagate the binding. In this sense, an Elastic IP address belongs to the account and not to a virtual machine instance. It exists until it is explicitly removed, and remains associated with the account even while it is associated with no instance. Amazon CloudWatch. Amazon CloudWatch is a web service that provides real-time monitoring to Amazon's EC2 customers on the resource utilization such as CPU, disk and network. CloudWatch does not provide any memory, disk space, or load average metrics without running additional software on the instance. Amazon provides example scripts for Linux instances. The data is aggregated and provided through AWS Management Console. It can also be accessed through command line tools and web APIs. If the customer desires to monitor their EC2 resources through their enterprise monitoring software, the metrics collected by Amazon CloudWatch enables the auto-scaling feature to dynamically add or remove EC2 instances. The customers are charged by the number of monitoring instances. Since May 2011, Amazon CloudWatch accepts custom metrics that can be submitted programmatically via web services API and then monitored the same way as all other internal metrics, including setting up the alarms for them. Automated scaling. Amazon's auto-scaling feature of EC2 allows it to automatically adapt computing capacity to site traffic. The schedule-based and rule-based auto-scaling mechanisms are easy to use and efficient for simple applications. However, one potential problem is that VMs may take up to several minutes to be ready to use, which are not suitable for time-critical applications. The VM startup time are dependent on image size, VM type, data center locations, etc. Lack of IPv6 support. Despite an announcement in the year 2011, EC2 doesn't yet support IPv6 reliability. To make EC2 more fault-tolerant, Amazon engineered availability zones that are designed to be insulated from failures in other availability zones. Availability zones do not share the same infrastructure. Applications running in more than one availability zone can achieve higher availability. EC2 provides users with control over the geographical location of instances that allows for latency optimization and high levels of redundancy. For example, to minimize downtime, a user can set up server instances in multiple zones that are insulated from each other for most causes of failure such that one backs up the other. Higher availability database services, like Amazon Relational Database Service, run separately from EC2 instances. Issues. In early July 2008, the anti-spam organizations Outblaze and Spamhaus.org began blocking Amazon's EC2 address pool due to problems with the distribution of spam and malware. On December 1, 2010, Amazon pulled its service to WikiLeaks after coming under political pressure in the U.S. The internet group Anonymous attempted to attack EC2 in revenge. However, Amazon was not affected by the attack. Amazon's websites were temporarily offline on December 12, 2010, although it was initially unclear if this was due to attacks or a hardware failure. An Amazon official later stated that it was due to a hardware failure. Shortly before 5 a.m. ET on April 21, 2011, an outage started at EC2's Northern Virginia data center that brought down several websites, including Foursquare, SpringPad, Reddit, Quora, and Hootsuite. Specifically, attempts to use Amazon's Elastic Disk and database services failed, or were slow. Service was restored to some parts of the data center by late afternoon Eastern Time that day. Problems for at least some customers were continuing. As of April 25, 0.07% of EBS volumes in one zone have also been lost. EBS failures were a part of normal operation even before this outage and were a risk documented by Amazon, though the number of failures and the number of simultaneous failures may find some EC2 users unprepared. On Sunday, August 6, 2011, Amazon suffered a power outage in one of their island availability zones. Lightning was originally blamed for the outage. However, on August 11, Irish energy supplier ESB Networks dismissed this as a cause, but at time of writing, could not confirm what the cause of the problem was. The power outage raised multiple questions regarding Amazon's EBS infrastructure, which caused several bugs in the software to be exposed. The bugs resulted in some customers' data being deleted when recovering EBS volumes in a mid-write operation during the crash. August 8, 2011, saw another network connectivity outage of Amazon's Northern Virginia data center, knocking out the likes of Reddit, Quora, Netflix and Foursquare. The outage lasted around 25 minutes. Another Northern Virginia data center outage occurred on October 22, 2012, from approximately 10 a.m. to 4 p.m. PT. Edmodo, Airbnb, Flipboard, Reddit, and other customers were affected. Anonymous claimed responsibility, however Amazon denied this assertion.